Hi viewers, this is Sri Ramulu, degree lecturer in physics. My YouTube channel is s.s space physics. So before watching this video, please subscribe it. Next, entropy and a disorder. So what is the relation between entropy and disorder? Is there any relation between the entropy and disorder? So that is we have to know by using this PPT. With an increase of entropy, the thermal agitation and hence order of molecules of substance increases. That is, the increase of entropy implies the transition from order to disorder. What is saying? With an increase of entropy, if want to increase the entropy, what it has to do? The thermal agitation, because of temperature, disorder of the molecule of the substance increases. So when the disorder of the molecule of the substance increases, then increase in temperature, then it leads to the increase in entropy. Okay, so when disorder of the molecules of the substance increases, then entropy also increases. So that is, see what he's saying, increase of entropy implies a transition from order to disorder. So if you want to increase the entropy, then what we have to do? Order to disorder we have to move. Thus, principle of increase of entropy is intimately connected with less disorder state of affairs. So what? Entropy, increase of entropy, it is simply connected to what? Less disorder, less order. Less order means more disorder, that is a meaning. Okay, less disorder means less order means more disorder. Okay, as disorder increases, what happens? Entropy also increases. A system possessing high entropy should be in a great disorder. Am I right? So if the disorder is more, then entropy is also high. Thus, entropy of substance in gaseous state is more than in liquid state, because molecules are free to move about a great disorder in gas than in liquid. So comparing to liquid, in liquid molecules having the greater, so molecules are having the greater order in liquid, comparing to what? Comparing to gas. So in gas the molecules have the different directions, means disorder is more in gas, but lesser disorder or more order in liquid comparing to gas. So that is why gas has high entropy and it has a low entropy. Why? Because it has high disorder and a liquid has low disorder. Moreover, entropy is more in liquid state than solid. So if you see, if you compare the liquid and a solid, if comparing to solid, liquid has a more disorder. Okay, more disorder, and it has a less disorder. Less disorder means less entropy. More disorder means more entropy. So that is why liquid has a higher entropy than the solid. But here liquid has a lesser entropy than the gas. Okay, see here. So gas has higher entropy than the liquid, but liquid has higher entropy than the solid. So moreover, entropy is more in liquid state than the solid. So that is what I said here. When ice is converted into water and then into steam, entropy of disorder of the molecule continuously increases. Okay, suppose ice in solid state having the less entropy. Now when solid is converted into liquid, so liquid has a somewhat less less order, means more, somewhat more disorder comparing to solid. Okay, so that is why its entropy increases. Okay, and if we move into steam means it is a gas. So gas, in gaseous state, what? Gaseous state, more disorder present, so that is why more entropy present. So here entropy gradually increases, right? And then steam, entropy and the disorder of the molecule continuously increases. So here entropy continuously increases. Thus, when the temperature of system is decreased, the amount of entropy and disorder in it decreases. So here entropy decreasing means disorder also decreasing. Okay, this is the inherent tendency of a universe to produce from less order state to more disorder state. So in the universe also having less order and having more disorder. So that is why entropy of universe always increases. So that is also we have the what about the entropy of universe, that PPT also I will provide. Therefore, entropy of a substance is a measure of degree of disorder. So see, entropy definition is what? It is a measure of degree of disorder. That is called entropy. Prevailing among its molecules, just as the temperature is a measure of degree of hardness of a substance. Okay, so how the temperature measure the hardness of a substance? In the same manner, entropy also measure the disorder of the substance. Okay, at the absolute zero mean very low temperature, lowest temperature. At absolute zero temperature, at absolute zero temperature, the thermal motion completely disappear. So the disorder and entropy tending to zero. So more here, what at absolute zero means it is at whatever things present at this point, all the substance present in solid state only. Why? Because very low temperature it is. Then in solid state having the entropy less. Okay, so why entropy less here? Molecules having the more order, less disorder. So less disorder means less entropy. So and it very much less means comparing here, all the molecules may have the all the molecules may have the more order. So that is why disorder is zero, then entropy is also zero here. And the molecules of the substance are perfect order, that is well arranged. Okay, here perfect order present at 0 Kelvin, that is a solid and perfect, all the molecules may have exactly order. So that is why disorder is zero, so that is why entropy also zero. Next, this is the third law of thermodynamics, which states that entropy of system is a measure of molecular disorder in it. So already we have studied the thermodynamic laws of thermodynamics. There are the two laws are there. Already first law and a second law. First law, it is a dq is equals to du plus dw, that is we know already. But what is the second law? Second law is dq is equals to tds. dq is equals to tds. Am I right? So and there are like these two laws, and third law is this one, measure of entropy is a third law. This is also statistical interpretation of entropy is as given by Boltzmann. So Boltzmann statistical formula also we have, that is what is this one. Boltzmann introduced a relation between the entropy and disorder. So that is a disorder and it is entropy, that is S is equals to K log omega. Omega is what? Simply disorder, where K is the Boltzmann constant, S the entropy of the system, omega or W is the disorder parameter, which is a thermodynamic property of substance in a given state. So like this, it is a disorder, friends. So don't forget watching this video till the end. Okay, friends, thank you.